Howdy, we are the WiHydra Full Spectrum Wi-Fi Sniffer Capstone team, and this project is sponsored by Lockheed Martin. So for our problem statement, our main goal of this project was to fully eliminate network blind spots. Network blind spots are whenever there's on a network, there's unmonitored channels which attackers can use to infiltrate and attack networks undetected, and this is a huge concern in the industry as a majority of teams really deal with this issue. And so there are some current solutions which partially deal with this problem, main ones being Wireshark and Kismet, and these don't fully eliminate network blind spots as they implement channel hopping, which instead of simultaneously monitoring all channels, they do a round-robin approach of monitoring a single channel at a time. So for this project, we developed WiHydra using an agile methodology approach, and WiHydra is a synchronized distributed system of 14 ESP32s. It is a fully modular system that's fully embedded onto a Raspberry Pi, and it allows for simultaneous capture of all 2.4 gigahertz channels, and also provides the users with a real-time web user interface in order to analyze the system. And so some of the features that we put into this project is first and foremost the full spectrum Wi-Fi coverage. So again, this allows for no network blind spots. Additionally, zero packet loss and data fidelity. Additionally, we have industry standard PCAP compatibility, so we can export data that we captured to a PCAP in order for further analysis in tools like Wireshark. Also real-time visualization, so users can see what's going on with the system in real time, and then also an interactive analysis. And so here we have the full system design, and as we can see, it's really in a three-stage data pipeline, starting out with the data collection, which is the ESP32 modules. These are all responsible for sniffing off the 2.4 gigahertz band. Each one has their own channel, and it captures all the data or management frames and sends that over to the collector on our Raspberry Pi for data processing. Now, data processing is mainly just a synchronized deduplication of packets as well as parsing of metadata. So after processing is done, it goes over into our SQLite database for storage, as well as updates into our user interface for real-time user interactability. And so here we have a demo of the user interface. This is the dashboard screen. As you can see, at the top of the screen, we can start and stop. And then once we started it, we are seeing updated traffic in real time as data is being collected by the system. And here we have the analysis page. And on here, you can see the different packets that we're receiving and some of the information such as SSID, MAC addresses, channel, and timestamp. And so with these, again, you can start and stop, but also we have different filters. So you can filter by different properties such as the SSID in this case, which we're only filtering for Miss Rooster SSIDs. And additionally on this page, we have the exporting PCAP and export CSV. So if you wanted to, you could export these into different file types in order for further analysis. And here we have our system evaluation. So for our system, we evaluated its performance in Docker Desktop, where we were able to see the backend, our SQLite database, and also our collector script interacting with each other and seeing those updates real time with the Raspberry Pi. And then also we conducted a lot of unit testing to test the functionality of the system. With that, thank you very much.